Here we go.
12.1 tangent lines. A tangent is a line in the plane of the circle that intersects the circle in exactly one point. So it's a line that's coming through the plane space and it's touching the circle in exactly one point. That point is referred to as the point of tangency. Alright, so the tangent is the line. The point where the circle and the tangent meet is your point of tangency. In this case, BA is a tangent ray, and BA with the line above it is your tangent segment. Alright, so our first theorem. If a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So if you have a tangent, it's going to be perpendicular to your radius of your circle. So in this case, line AB is perpendicular to radius OP. They form a right angle. Alright, so let's move on. Alright, so first example. In this case, line segment ML and line segment MN are tangent to circle O. What is the value of variable x? Well, two things we already know here. If we have two tangents and we have a circle, then OL and ON being radiuses should be perpendicular to the two tangents. So that means ON meeting MN form a right angle right here, and OL and LM meeting form a right angle here. Well, essentially what we have now is a quadrilateral. So in order to find x, all we need to do is take our sum of a quadrilateral, set it equal to the four angle measures we have, so 117 plus 90 plus 90 plus x. We're going to combine our like quantities or like terms, subtract it, and solve for x. Alright, so this is 180 plus 117 is 297 plus x equals 360. We need to move the 297 to the other side, so we subtract it from both sides, and we should get x to be 63. Alright, and so that's all they wanted. They wanted the value of x. Go ahead and push pause and try example 2 on your own before I get to it. Hopefully you push pause. Example 2, ED is tangent to circle O. What is the value of x? Well, once again, we have a tangent segment ED, which meets circle O at point D. OD here is a radius, which means it's going to be perpendicular to our tangent line. So now we're looking for a measurement that is a part of a triangle, and we know two of the other angles. So we're going to take everything and set it equal to 180. So 180 equals 90 plus 38 plus x. Go ahead and add together these two measurements. You get 128 plus x equals 180. We'll subtract 128 from both sides. And in this case, we get x to equal 52. All right, so let's try something a little harder. All right, this time we have a horizon problem. All right. Jasmine is riding an airplane at an altitude of about 6.5 miles above the Earth. How far from the Earth can she see if the Earth's radius is about 4,000 miles? All right, and so what this picture is indicating to us is it's trying to relate circles to horizons and flying above the Earth, essentially. All right, and so let's assume that this is Jasmine's plane here. Jasmine is 6.5 miles above the Earth's surface. The radius of the Earth was given to us. It's given to us as 4,000 miles. So this is one radius. This is also a radius. And they're asking how far on the horizon can Jasmine see? So we're looking for x here. Well, if we remember correctly, the radius is perpendicular to our line of tangency, or perpendicular to our tangent line. So that means this forms a right angle. If that's true, we have a right triangle. So in order to solve a problem for a missing side length in a right triangle, we're just going to use the Pythagorean theorem. A squared plus b squared equals c squared. Because this radius is our A, the side we're looking for is B, and this whole piece together is C. So let's just plug it in and see what we get. So we've got 4,000 squared plus b squared. Well, in this case, we're going to change this to x. We want this to be x. Equals 4,006.5, or 4,006.5 miles squared. And so now we just want to solve this using the Pythagorean theorem. So we would square both of these and then subtract it over. And when you do that, you get x squared equals a really big number, 52042.25. So 54,042.25 miles. To undo the squaring, we have to essentially square root both sides. So we're going to square root both sides. And you get x to equal 228.13 miles. And so that is how far on the horizon Jasmine can see. All right, theorem 12.2. Theorem 12.2. Sticking with tangency and circles, Theorem 12.2 states that if a line in the plane of a circle is perpendicular to the radius at its endpoint on the circle, then the line is tangent to the circle. So what they're saying is if you have a radius that is perpendicular to your line of tangency, then you can verify that it is a tangent to that circle. So if you have a line in space that intersects a circle at a single point, and the radius of that circle happens to also be perpendicular to that line, you can state that that line is a tangent line. So it's more of what we've already seen, it's just saying it backwards. All right, so example 1. Is segment ML tangent to circle N at point L? So they're asking us is if this line meets this line at a right angle, essentially. So in order to test whether or not this is a right angle, we're essentially testing whether or not this is a right triangle. And in order to do that, we're going to test and verify the Pythagorean theorem. So let's plug in our values into Pythagorean theorem and see what we get. A, B, C. So A squared is 7 squared, plus B squared is 24 squared, equals 25 squared. So these two, 7 squared, 49, 24 squared? Ooh, that's the question. 24 squared, let's get a calculator. Do my head, possibly. Need a calculator. Pause the movie. All right, so 24 squared, 576, equals 25 squared, 625. All right, 49 plus 576 is 625. So since the two of these values are the same, we know this is a right triangle, which means ML is a tangent. Example 2 is asking the same question. Is MN a tangent to circle P at point N? So they're asking, does MN perpendicular to NP? So is this a right triangle? So we'll test it with the Pythagorean theorem. So 5 squared plus 12 squared equals 13 squared. So 5 squared is 25, 12 squared is 144, 13 squared is 169. Adding these two together, you get 169, which is equal to 169. So yes, this is also a right triangle, which means MN is a tangent. All right, so our next example says, what is the radius of circle C? This time, instead of testing whether or not we have a right triangle, they're telling us we already know we do. And we're looking to figure out what the radius is. So we're once again going to be using the Pythagorean theorem and trying to solve for a missing side length. So in this case, we know Pythagorean theorem, a squared plus b squared equals c squared. Our short side, or just our radius, is a. This is b. This entire measurement is c. All right, so this is essentially becoming x plus 8. And so we have to account for it accordingly. So let's plug in our values and we're going to see something special takes place. So x squared plus 12 squared equals x plus 8 squared. The left side of this, just x squared plus 144. But on the right, we have x plus 8 squared. That's a binomial quantity, meaning that the only way to multiply this or square it out properly is to use FOIL. So we're going to FOIL this out, and hopefully you remember FOIL from algebra 1. So first, so that's x squared. Outside, which would be 8x. Inside, which is 8x. And then last, which is 64. You might also remember being called crab claw as well. It does look like a crab claw. So the last thing you need to do is combine your like terms in the middle, and you've got x squared plus 16x plus 64. So now we know what the right side of our equation equals. It equals x squared plus 16x plus 64. So now in order to solve this, we need to bring all of our variables, or in this case, like quantities to one side, constants to the other. And so when we do that, we're going to notice that the first thing I would do would be, let's go ahead and subtract x squared from both sides. Because in this case, we have two x squareds that are going to cancel out, and it's going to save us some work in the long run. So when I do this, I've got 144 equals 16x plus 64. Now this is just a traditional algebra problem. We need to bring the 64 over and then solve for x. So subtract 64. You've got 16x equals 80 divided by 16. And in this case, x equals 5. So your radius has a length of 5. Go ahead and try example 2. Pause the video. Go ahead and try example 2 before I get to it. See if you can do it without me. All right. Question 2. What is the value of x in the diagram to the right? So once again, we're looking for our radius. This is our radius. This is our radius. But remember, in order to find this, we have to use the Pythagorean theorem. So we've got A, we've got B, and we've got C. So we're going to take a squared, so x squared, plus b squared, which is 24 squared, equals x plus 18 squared. All right, x squared stays the same. 24 squared, this time I know it's 576, equals x plus 18 squared. Well, once again, it's a binomial quantity. I have to FOIL this, not factor it. Oops. I have to FOIL this. I've got to FOIL it out. So in order to FOIL this, let's change colors just because. First, x times x is x squared. Outside, 18 times x is 18x. Inside, 18 times x is 18x again. And then 18 times 18, let's see, what is 18 times 18? My calculator. 324. All right. 18x plus 18x gives you 36x plus 324. And in the front you have x squared. So this is your new quantity for the right side of your equation. And so we're going to plug it in accordingly. We're going to have x squared plus 36x plus 324. All right, so once again, I'm going to start off by seeing if I can subtract the x squareds. So let's subtract the x squared on the left from the one on the right. Well, in this case, we lucked out. They cancel out again. So 576 equals 36x plus 324. We're going to subtract 324 from both sides. So that gives us 252, which equals 36x. The last thing we need to do to find our radius is to divide both sides by 36. And so in this case, x equals 7. So your radius for this particular circle happens to have a length of 7. All right, so looking at the last part of our notes, winding down here, we're getting towards the end. This last theorem that we have here states that if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So two segments are congruent if they share a common endpoint outside the circle, and they both happen to be tangents. So in this case, we have a tangent AB and a tangent BC. Since they're both tangents to circle O and they share endpoint B, then they must themselves be the same length, or they're congruent. So we're going to use this information to find missing measurements and other problems. So example 1, O is inscribed by triangle ABC. What is the perimeter of triangle ABC? Well, in order to find the perimeter, we have to find these other missing sides. But we just learned that if two tangent pieces share a common endpoint, in this case like point A, and they're both tangent to the same circle, they must be congruent. So if AD and AF share endpoint A, and they're both tangent to circle O, then AF has to also be 10 centimeters. We can use that same logic to find the length of CE, because in this case, CF is 8, and then CE, also tangent to the same circle, sharing endpoint C, has to be the same measure. So CE is 8 centimeters, because they're congruent. And then last but not least, DB and DE share the exact same properties. So that means BE is also 15 centimeters. So in order to find the perimeter of a shape, you add up all the sides. So we're going to add up all the measurements we have. So we're going to take, well, the top measurement, AB here for this triangle, has a length of 25. So we're going to take 25 plus AC here, which has a total length of 18. And then the total length of CB is 8 plus 15, which is 23. So our perimeter for our triangle equals, well, 25 and 23 is 48. 48 plus 18 is 66. In this case, centimeters. Using that same idea, go ahead and try example 2. It's going to be a little different because you're going to have a variable, but see if you can use the same properties before I get there. Question 2. Circle O is inscribed by triangle PQR, which has a perimeter of 88 centimeters. What is the length of QY? All right, so a couple of things we know here. PX and PZ should both be 15. ZR and RY should both be 17. We don't have any way to tell what QX and QY will be, so let's just let them both be the variable X for right now. It tells us in the beginning of the problem that our perimeter is 88. So what we're going to do is we're going to set all of those measurements equal to 88 and solve for X. So 88 is going to equal 15 plus 15 plus 17 plus 17 plus X plus X. So we've got 30 plus 34, that's 64. So we've got 64 plus 2X equals 88. We'll subtract 64 from both sides. We're going to get 24 equals 2x. Divide both sides by 2, and you get x equals 12. So if x equals 12, that means qy also equals 12. Go ahead and try question 3 on your own. Pause the video. It's a lot like question 1. Well, let's see if you did question 3 correctly. LR is 8, which makes LO 8. ON is 5, and T is also 5. RM is 14, so TM, which T's a little off space here, is also 14. So in order to find the perimeter of this triangle, you just need to add everything up. And when you add everything up in this problem, you get that the perimeter is 54 units. So the last part of your notes is your lesson check, which you're going to do on your own. If you'd like to know if you got the answers right, just check the complete answer key or note sheet on Schoology.